Questions? Okay. To next is f times g of x. And for this one, we're going to multiply the two of them. Right? When you multiply, you basically do the right, the FOIL, okay? And I know a lot of you guys, I mean, most of you guys are comfortable with doing that. So maybe if you need questions on how to do that, maybe we can get together one-on-one and take care of it. In the end, you get another polynomial, and the domain is also all real numbers, no questions asked. The one I'm going to focus on is this, f over g of x. You are going to divide the first function by the second function. Okay. Now, students always ask me, okay, so now do I need to simplify this any further? Do I need to factor it out? Well, let's see. If you factor out the top, does it help you in canceling anything out from the numerator and the denominator? Not really. If it's not going to help you go a step further and cancel things out, you don't have to factor it out. Does that make sense? So this is just good enough for me. All right. The domain, however, we have a rational function. So 3x minus 4 should not equal to 0, right? Well, what value makes the denominator 0? 4 over 3. So that means my domain is everything but 4 over 3. So it's negative infinity to 4 over 3, 4 over 3 to infinity. Okay? Questions? Okay. Composition of functions. F of g of x. You guys have seen this in algebra 2, right? Whether or not you remember exactly what it was is another story, but you've seen it before. F of g of x, these are called compositions of functions because they're basically nested functions. They're created when you take one function and you insert it into another one. We've learned this notation, f of g of x. You may also have seen this notation, right? Have you or have you not? Yes, no, yes, okay. So let's do one here. We need to find f of g of x, g of f of x, and f of g of 2. Okay. So for the first one, where we have to find f of g of x, here's how I do it. There are lots of ways to do it. The outer function here is f of x, right? The outer function is f. So I start out by writing f of x. Now, what I need to find is f of g of x. So what does that mean? That means x gets replaced by g of x, right? So in the function, wherever I see an x, I'm just going to replace it by g of x. So look, this is g of x. So in my function, it's 2 times x, which is this, g of x now, squared minus 1. So do you see the purple 2 blah squared minus 1? It's the same as f of x, 2 blah squared minus 1. And then you have to simplify this. So this will be 2 times x squared plus 6x plus 9 minus 1 which is 2x squared plus 12x plus 17. That's f of g of x. Okay, you guys okay with this? Yeah, okay, so let's do g of f of x. G of f of x, right? I start with g of x. G of x is x plus 3. So now for x, I'm going to insert f of x. Well, what's f of x? 2x squared minus 1 plus 3. So this is 2x squared plus 2. Okay. Questions? Okay, so the next one, I want.
Do you
f of-
divide the 2 out?
So you don't have to because it's not going to make it any simpler. Like it's not going to help you cancel things out. Yeah. Okay, so f of g of 2. Okay, so look, there are two ways to do this. One is, here we found f of g of x. So you can just plug in the 2 in here, if you've already found it before. But suppose you hadn't found that one before, and you're starting fresh with f of g of 2. The best way to do it for this one is to start from the inside. You start from the inside, g of 2. And what's g of 2? It's 2 plus 3, 5. So now when you zoom back out, you have f of 5, which is 2 times 5 squared minus 1, 49. Both ways are perfectly acceptable, and you get the same answer, obviously. But if you hadn't already found f of g of x, that's how you would do it. Okay, let's do one more. Here, I need to find f of g of x. So I start with f of x. F of g of x is root. For x, I put in this one. Okay, minus 1. So this is, let's square, right? How do you square that red one? You square the first one. The inside term is 2 times this, negative 1, times this x, negative 2x. And then you square the last one, plus 1. Then I have minus 1. So this is x squared minus 2x. If you have questions, you can chat them to me as well. Okay, let's do g of f of x. I'm going to start with g of x. It's x minus 1 squared. So what's g of f of x? Okay, this is a little bit more complicated, so I'm going to start with a bracket. For x, I put in f of x. Minus 1 squared. Okay. So now look, I need to square this. All right, so let's go step by step. So mistakes sometimes do carry over here. But the thing is, this part is independent of what we're going to do now, if that makes sense. And then as far as brackets, you don't need brackets. It could also have been parentheses, if that makes you, I know brackets can be scary sometimes, right? And like, right? It's just weird. I admit, I think, let's go with parentheses here. I think it's a better option. So here's how we're gonna do this. When you have a binomial, two terms, and you have to square it. First, square the first number, x minus 1, right? If you square the square root. Next, square the last number, you get plus 1. Inside, you're going to get 2 times this, negative 1. So negative 2 times this, negative 2x minus 1. Okay? Square the first, square the last, and then the inside is 2 times first term times second term. So finally, this will be x, the ones go away, minus 2 root x minus 1. And that's it. You cannot do anything else.
Miss Malikian, I thought that when you had a square and a square root, it just like cancels out the square root.
Yes, that's why when I first squared this term, I only got x minus 1 without the square root.
Okay. So you're like kind of factoring it. You're not just like taking away the square root.
Kind of. So like when you had this, right? First you square this term and you get x minus 1. Then you square this term and you get plus 1. But then the middle term, right? Remember how when you had like a minus b squared, it's a squared minus 2ab plus b squared. So it's this term that you have to do 2 times this times this. That's where like the square root stays.
Could you go over that trick to get the middle term again?
Yes. So if you have, yeah. All right. So if you have, let's say, x minus 3 squared, right? You square the first term, you get x squared. You square the last term, you get positive 9. The inside is 2 times negative 3, negative 6 times x. So in this problem here, okay, in this problem here, you square the first term, you get x minus 1. You square the last term, you get plus 1. And in the middle, you get 2 times negative 1, negative 2 times this, negative 2 times the root. Okay. Okay, so when we have now f of g of 2, we're going to start from the inside. G of 2 is 2 minus 1 squared, 1. F of 1 is root 1 minus 1, 0. Okay? Questions? Okay. All right, so this one. This is like major, I meant for that to be like a little star, asterisk. This is major calculus business here, okay? We want f of g of 0. Now remember what that is. That's f of 0 plus g of 0. Okay, so you go to the function, and now you, you go to the graph. On the graph, you have 3 functions graph. You want f of 0, so identify where f of x is. That's the blue one. You want f of 0, it means the y value when x is 0. The y value for the blue when x is 0 is about -6, right? So that's -6. Well, now you want g of 0. Okay, g of 0, when x is 0, g, the red one, is also -6. I am estimating a little bit. So together, that's -12. Okay,
How did you get -6?
for which one, the red or the blue?
Both.
So you want f of 0, right? You want the value, the y value of f when x is 0. When x is 0, the y value of f is here, -6. Okay, that's why I was testing you on all that stuff, in the last test and quiz, right? Because this was coming up. I'm telling you, I'm from the future, right? So these are the things when I want to like focus on for the next unit, right? Okay, now we have f of g of 4, -4, sorry, f of g of -4. Same deal. That's why I was stressing this from, for example 2. We're gonna start from the inside. Okay, so what's g of -4? When x is -4, what's the g value? -4. So now this is gonna be f of -4. Okay, f is the blue one. When x is -4, what's the value of f? When x is -4, the value of f is -4. So that is my final answer, right? Very much like this nested business. Okay. Another thing for calculus, this next page is all like straight out of calculus. Another thing for calculus is not to just be able to find f of g of x, but if you're given f of g of x, can you then find two functions from which it came? Can you go in the opposite direction? Well, so for example, look at this one. You have h of x is equal to 3x minus 1 squared. You want to find two simpler functions that when you put one inside the other, you get h of x. The way I like to think of it is, look at h of x. Now pretend you zoom out, right? When you zoom out, there is always going to be this outer function, right? So look at this one. When I zoom out, what do I see? I just see some stuff squared. So stuff squared or x squared, that will be the outer function, f of x. And then when I zoom back in, what's inside of this thing? 3x minus 1. That will be my second function. Okay? So if you think about it, if I take g of x and I insert it into f of x, do I get the first thing back? I do. So that's kind of what we need to identify. Can there be more than one answer? Yeah, sometimes it's kind of obvious that there's only one, sometimes there might be two, and that's okay, because in calculus, we kind of narrow down which we can consider to be the first and the second. Okay, so here, that's what we have to do here. We have to decompose. So any ideas for what the outer function f of x can be and what the inner function g of x can be? You can be wrong, but yell something out for the outer function.
1 over x squared.
1 over x squared works for me, right? That's like the skeleton. And then when I zoom in on the inside, I have x plus 2. Okay, how does that sound? Good, okay. What about this one? Anybody want to take a guess at this one? outer function, inner function.
F of x would be x minus x, absolute value of x minus 3.
That works for me. Gavi, what do you think the inside function will be?
5x plus 2.
5x plus 2. Fabulous. I know you were raising your hand before as well. Awesome. Okay. Important skill in calculus. Okay. Okay. Now, last thing we're going to do is, getting to this idea of limits again. So remember when we talk about limits, we're not talking about an actual value of a function. Here, right, when I had to find f of -4, I needed to find, like, pinpoint the exact value of the function. That's not a limit. A limit is, what is the trend? That's the limit. Okay, so before we tackle this one, I just want to, go back and talk about fractions for a minute, right? If you have, let's say, 1/10, right? That's 0.10, right? Or 0.1. Now, if I make this denominator smaller, right? So I have now 1/5. How much is that? It's like point what? What's happening? Let me make it let me make it even smaller so it's easier for us. So I'm gonna make the denominator smaller. Instead of a 10, I have a denominator of 1. Now I have 1/1. What's the whole fraction? 1, right? Okay, now, what if I make it even smaller? What if I do 1/0.5? What's my fraction now? 1/0.5 is a 2, right? What if I make it even smaller, right? So what's happening? As the denominator gets smaller, what's the fraction? What's happening to the fraction? It gets bigger, right? So the smaller denominator you have, the bigger your fraction is, right? And then it also works in the opposite direction. So if you go in the opposite direction, from 0.5 to 10, as the denominator gets bigger, the fraction gets smaller, right? So one way to think about it is, if you have a pizza and you're dividing it between 2 people, everybody gets, think about it, close your eyes, 1 pizza, 2 people, how much does each get, right? Now, that's a lot of pizza for 1 person, right? Now, imagine you now are not dividing it between 2 people, but now you're dividing it between, I don't know, 1,000 people. How much pizza are each one of you gonna get? You're lucky if you get like a grain of salt at this point, right? So as the denominator gets bigger, the amount gets very, very small. Okay, so now look at this. It says describe the behavior of f of x as x approaches 0. Okay, so I have f of x is equal to 1 minus 1/x. As x approaches 0 means as it gets small, very, very small, 0.99999, or sorry, 0.0000001, okay? So as this gets very, very small, what happens to the entire fraction? It gets very, very large. It almost approaches infinity, right? So now, what's this function? It's 1 minus this. What's 1 minus a very large number? What's 1 minus 1,000?
negative number?
Negative, yeah, but how big of a negative number? Like negative 999, right? So 1 minus a very large number is a negative number, but also a very large number. So if I have something like 1 minus infinity, it's just negative infinity. Okay, let's think about that one more time. If I have 1 minus a million, what value is it? It's negative, but almost a million, right? So that's sort of what we're talking about. Hey, Tal. And then we're on the last page of our notes. And then in part B, it says describe as x approaches infinity. So it gets very, very large. So look, I have f of x is equal to 1 over a 1 minus 1 over x. Now, as x gets very, very large, what happens to 1 over x? Does it get big or small?
Small.
Small. It gets so small, it's almost 0. It's like 1 divided by a million for your pizza, right? The amount you're going to get is about 0. And so now what's 1 minus something close to 0? About 1. Okay? So that's sort of the idea here. One thing before I let you guys go is when it comes to infinity, we are never allowed to plug in infinity into an expression. So for example, notice here, I never wrote 1 over infinity, right? I might have been arrested for doing that. You cannot do that. That is like so illegal. It's not even like, don't ever get caught writing something like that. You might think it 1 over an infinitely large number, but we don't ever write it. We don't ever write infinity times 1. No, 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 we cannot. We can only put in expressions numbers that are defined, numbers that you can pinpoint. If you can't pinpoint something like infinity, you can't put it in an expression. E to the infinity, I can't even tell you, like I don't even, right? If you happen to write it down by mistake, erase it, tear off the paper and swallow it, something, but you can't get caught with it, okay? All right, okay. So that's what I have for you guys today. So if you have questions, please say. If you don't have questions, the homework for this is due next time, as it says on the lesson plan. Okay. All right. I want to mention one other thing. Last class, I may have been acting a little funny. My mood was a little subdued. I was just dealing with some personal issues. It may have seemed like I was irritated with, getting questions and stuff. If that was the case, I really do apologize. I just haven't been able to get it off my mind. There were just some personal things on my mind. And, it was, my mood was very much subdued. So please don't ever feel bad about asking questions. If you don't want to ask questions in front of everybody, chat them to me. That's totally cool, right? But like, listen, G period is one of my favorite periods of the day, and I always look forward to G period. So, I just want to make sure there are no hard feelings, right? Okay. Having said that, again, if you don't have any questions, you don't have to stay, but if you have questions on homework or on anything else, I will take that right now. Okay, Roy.
Can you do number 13 on the homework?
I can.
Thank you.